Our next case study for design is the following: a power n, b power m, c power n plus m, and n comma m is at least 1. So what this says is the underlying alphabet is ABC. It contains set of all strings over ABC such that the number of C's read is the sum of the number of A's and the number of B's. So A, B, C, C is valid. A, B, C, C is valid. There is no relation between n and m. One can read any number of A's, any number of B's. Only thing is the sum of this must be same as the number of C's read. This is also a valid string, and we may read 3 A's and 2 B's, then 5 C's. Okay. So what we do is the following. When we read A, we store a symbol, say X. For all of this we store this symbol, and then when we read a B, we again store this. You can use the same symbol or different symbol, doesn't matter. Now when we start seeing this, we start performing pop. So for this we pop this, for this we pop this, for this we pop this, because we don't need to differentiate between this and this, because we focus only on the count and there is no condition or constraint on A as well as B. We just have to ensure this sum is same as this, which is why I am using same symbol. Okay, so it may so happen that you may read more A's than B's, or you may read more B's than A's. All that is immaterial as far as C is concerned. C is only interested in the count. Fine. And as part of design, we should only ensure that we read at least one A and at least one B before we start reading C's. Fine. And let's implement this design. Delta of Q0 comma A, start symbol is Z0. Then we go to Q1 and we push, in this case say X followed by Z0. Then we are in Q1, we read couple of more A's, top symbol is this, we continue to stay there and push X. This part takes care of A power n, and when you come to Q1, it is ensured that you have read at least one A. So the condition is checked. Now I am in Q1, I read a B, top symbol is this, then let me go to Q2 and push X. Now stay at Q2 and read couple of more B's, so which means I get to see something like this. Okay. Now we are reading at least one B and then reading subsequent B's through this. One can read any number. There is no relation between this and this. So now we are at Q2 and we read C, top symbol is this, we stay there and pop. Fine. Now Q2 comma C comma X, we get to see that Q2 comma epsilon, and stay there, read the next C and continue to pop using this. Fine. Now after some time, we are in Q2, we exhaust the input tape, and top symbol is Z0. So this ensures at least one A is read. This ensures at least one B is read. So which means there will be at least 2x on the stack. So we go through this. After that we may see couple of more. All that we go through and then we ensure the tape is exhausted. So now when we come over here, which means we have read all x, at this place we can stop the automaton. Okay, you can also stay in Q2 and empty the store and stop the machine. Fine. Now as always, when we read a B or C at Q0, we have to reject. And similarly, when you are in Q1, you read C, X, that is invalid configuration, reject. Similarly, after reaching Q2, you get to see A, X, it has to be rejected. Fine. And at Q2, B is push, Q2, C, X is pop. If you see a which means you are seeing an invalid string, it has to be rejected. Fine, so I am not listing those and one has to fill that as well. So this clearly tells you that delta is a transition function from Q cross sigma. We also write like this, so let me write sigma union epsilon cross gamma to Q and cross gamma star. And we see that for each of them we move to exactly one configuration or one state along with stack configuration. Therefore, this design is deterministic design, or it is a deterministic push down automaton. Here is our next language. It says it is W, say small c, and then WR. W is a string over A, B. And what is WR? WR is reverse of W. And C is some symbol. Symbol is like kind of a delimiter that separates W and WR. Okay. Fine. So you can even consider sigma to be A, B, C, and or C is from gamma, but usually gamma is associated with stack and every other symbol, something that is associated with the input tape, A, B, C in this case, they are part of sigma. Okay. So which means either you can say W is a string over A, B, star, A, B star, or W is a string belonging to the set A plus B plus C whole star, or it belongs to this. Okay. And but this W and WR precisely uses AB and it does not use C, which is why this definition is given. And when we say this, then it may so happen that W can even take C correctly, which is why, to avoid that confusion, while defining, I am saying W is a string over A comma B star and C is a delimiter and sigma contains ABC. So just because sigma contains ABC, one should not think W is also over ABC star, and or just because W is over A comma B star, one should not think that sigma is actually AB and C is not part of sigma. Okay, so always we use gamma to talk about stack alphabet. Capital A, capital B, Z naught, X, they are all from this. And sigma is our input alphabet. Okay, so anything that we use in the input tape, A, B, C, all that should come from this. Fine? Yeah. So having made that point clear, let's focus on the design. So what it says is something like AB, C, BA is valid. AB, BA is the reverse of this, C is the delimiter. Or something like ABB, C, BBA. W is a string over AB star, which means W can be epsilon as well. So just C is valid. And ACA is valid. BCB is valid. Okay. Now, having given this picture, let's do the design. So, starting from Q0, we read A, top symbol is Z0, or Q0 comma B comma Z0. Because W is a string over AB, we just focus on these two. Fine. So when we read A or a B, what is that we should do? Remember, C is acting as a delimiter, which means when you scan W, simply perform push. And C will act as a switch and take you to the other side. When you start seeing WR, invoke pop and check whether the top symbol and the symbol red are one and the same and go for a pop. So which means the first part we perform push. This becomes Q0 comma A comma Z0. Let me go to Q1 and then push capital A followed by this and go to Q1, push this. For this capital A, for this capital B. Where do they come from? They come from gamma. Now I am in Q1 and I read A, top symbol is this, or I am in Q1, I read A, top symbol is B, or I am in Q1, I read a B, top symbol is this, I am in Q1, read a B, top symbol is this. So this says stay in Q1 and push another A, stay in Q1, push a B, it becomes top symbol is B, so which means we push A, below that B will be there. And in this case we stay here and push B, below that A will be there. And in this we push B, below that B will be there. Fine. So with this we ensure we have reached a stage where we have read the all of W. Correct? we have read all of W, and now we will take a switch and then start performing pop. Okay. So now delta of Q1 comma C. When you look at Q1 comma C, the top symbol could be capital A, or Q1 comma C and the top symbol could be B. So for this we go to Q2, we do not change the stack, neither pop nor push, we simply skip this symbol. So we go to Q2 and stack is unchanged. Fine. And one can also get delta of, I am in Q0, without reading A or B, you may read C, because W belongs to this. Top symbol is Z0. In that case, we go to Q2 and top symbol remains this. Fine, so which means we have just read C in this case, and in this case we are at Q2 and we want to explore some more. Fine. Now delta of, I am in Q2, we read small a, top symbol is capital A, which means there is a match. We read A and top symbol is capital A, which means this and this. So which means when you do WR, this and this are matching, 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 this and this are matching. If they are same, then perform pop. Similarly, Q2, read small b, top symbol is capital B, which means there is a match, perform pop. Fine. And as always, if you come across anything that is not defined, we say it is invalid, it will take us to a reject state. Now I am in Q2 and we have exhausted the input tape. Top of the symbol is this, then reach final state, or you can also empty the store and accept. Fine. So with this we read the first A or B, then we start reading A and B's. It can come in any form. AA can be there, AB can be there, BA or BB. So we simply perform push. Then we need to perform switch. When we see the C, we do not change the stack, we simply go to other state Q2. We may also come across a configuration or a input where W is empty because W belongs to this. So which is why at the start itself you may read C, Z0, go to this. Now switch is done, we are at Q2, now match is happening. Top is A and we read A, and our top is B and we read small b, for both we perform pop. Finally Q2 input is exhausted, top symbol is Z0, it's a valid configuration. So what is this telling us? If you look at WCWR, when you scan W and perform push onto the stack, and W will be inserted like this, right? The first symbol, second symbol and the last symbol. So eventually when W is pushed, and it will be WR when you look at it this way. So when you take the first symbol and then second, third, like this, from the top, it will be eventually WR. Which is why after we switch, when we start reading this part of the string, we see whether there is a match with top symbol, second top symbol, third top symbol, and so on. If there is a match, we accept. Fine. Here again, when we look at all these transitions, they are mapping to exactly 1, which means it is a deterministic machine. Now the interesting question is, what is the role of this C? Can we drop this and then still design a machine? What am I asking? Language is WWR. W is over A comma B star. There is no C. Now sigma is also AB. Suppose the language is this. Can we construct a pushdown automaton for this? That's an interesting question to explore. Let's explore that.